Hello and welcome to QED's Data 4 from part S5. So now we're looking at data from Karnataka. So I'm going to import the data as before. So let's talk the data from Burkina Faso here, but we'll just go over the top of that. So it'll be the same spreadsheet. Squint out and find each time. Now, Talux, which is the name of the subdivisions we're interested in. Karnataka. Import first rows variable strings. Make sure you do that. Yes. Okay. It gives you a warning because you're changing the data that was already in the memory. So imported it. Summary script statistics for the household size variable. As before, that's SU. Summary household size detail. Okay, so that the mean is 5.3 here. Standard deviation was 6. So if you remember the lecture when we introduced standard deviations, 2 standard deviations is 7, so there's quite a wide variety of household sizes around, as you can see from here. Because most household sizes are going to be within 2 standard deviations of the mean, but that's like within 7 each way. So there's a huge variety of household sizes. This also helps if you want to know how to get this. It's just tab 1. So you tab 1 of household size. Get this data so you can see that the biggest category is size of 10, 20% of households. A bit of a dip here, and there's a few households that are really, really big, like extended family households. Okay, so does it suggest that mean household size is greater than overall state of figure where it is 5.3? It's quite a few over 5.3. It could be. Hard to tell exactly because there's such a lot of variation in it. So it's hard to be sure, but it looks suggestive, but we can't be sure. It could just be a random sampling error, so we need to do the t-test. So t-test, that's the household size, is equal to 4.6. Okay, so it comes, and here's the output, and we need to decide which of these 3 sig values or p values is the one we want. Sorry, sig values, p values are sometimes called sig values. Where are we? Hypotheses are, so the alternative again is going to be greater than. So the mean size is 4.6 is null, the alternative is greater than, so we're only going to reject it if we get something bigger, not something smaller. So we want to know, we got 5.3, what's the chance of getting something as big as 5.3 if the real mean is actually 4.6? That's where this number here is the one we want to look at, so 0.09, so about 9%. So it's less than 10%, so it's a bit surprising, but it's not. It would make us doubt it, make us think, well, maybe we need to get some more evidence here, because maybe there's something going on, let's maybe do a bigger survey, or bear that in mind as a question mark. But because it's not that unlikely, it's almost 10% chance. By the standards that we normally apply in stats, you wouldn't say, okay, we're going to reject the null hypothesis because it's not less than 5% or less than 1%. So you can't reject the null hypothesis at the 5% level even. You can just about reject it at the 10%, but that's not a very strong result at all. So there's very weak evidence here that the household size is actually bigger in this taluk than it is in the whole state at 4.6. Yeah, so that's interpreting the results of the test. The results are they're indicative, but they're not really strong results. So we can't reject the null hypothesis. It could be that just through random error we've got this high number. It could be that the average is the same as it is in the rest of the states, but 10% is still a low probability, so it's worth doing more investigative work. We can't be confident that the household size is larger in this taluk. Okay, now we're going to rush on to the rush hour at Mexico City, but I'll leave that for the next video, our trip to Iztapalapa. But thanks for watching now.